This is G485 homework booklet question 26. Fairly straightforward question about various astronomical units. That's an unfortunate phrase. Various units used to measure astronomical distances. So we're asked to define the parsec and explicitly told to draw a diagram to illustrate the answer. So I'm looking for a diagram with an astronomical unit. So imagine the Earth orbiting around, looking at the side of the orbit, going up and down by one astronomical unit. Here's a distant star, and if that is at a distance of 1 parsec, then that parallax angle, the angle it appears to move as we move from the inline position to the extreme position, is 1 arc second. That is 1/3600th of a degree of a circle. So the definition then is the distance. Word distance was underlined on the mark scheme, so you've got to make it clear whenever you're defining a unit, what is it a unit of? It's the distance that gives stellar parallax of 1 arc second from the Earth. Or it's the distance from a base of one astronomical unit that subtends an angle. That's what that means. It subtends an angle of 1 arc second. So the distance from a base of one astronomical unit that subtends an angle of 1 arc second. They mean essentially the same thing. Obviously, they're both definitions of the same quantity. The star Tau Celti, I don't know, has a parallax angle of 0.275 seconds of arc. Calculate the distance of Tau Celti from the Earth. Well, distance in parsecs is this beautifully simple equation. It's not blindingly obvious why it's the case. It's something you can go and look up, but I think if I was you, I'd just encourage you to be learning that the distance in parsec is 1 over the angle in parsecs, so that turns out to be 3.64 parsecs. And then you're also asked to work that out in light years, and they've given you what the parsec is in meters. So the obvious thing to do is to take the number of parsecs we've got, multiply that by the number of meters in a parsec to get a number of meters, and then divide by the number of meters in a light year to get that in light years. That number of meters in a light year is in the formula booklet, and that brings you out at 11.9 light years. So that's G485 homework booklet question 26.